Let's see the motion of connected particles. So motion of connected particles or connected bodies. So we'll start with we'll just use two bodies. We'll use two bodies and do examples on those. So the first body we'll consider will be, let's see, number one, the pulley system. Okay, we'll consider only two bodies connected. Only two bodies connected will be considered. You can have as many as possible number of bodies connected. We'll be considering just two bodies connected. Okay, that will be in accordance to the syllabus for JPEG. You can have 10 bodies connected together with your pulley. So many bodies can connect with your pulley. You can have just two bodies connected. So we're looking at a case where the bodies are connected like this. This is a body. This body 1 mass M1. This is a pulley. This is body 2 of mass M2. Mass M2. So these two bodies, you can see they are connected together with this pulley. They are connected with this pulley. So you can have, let's see this way. Let's assume that M2 is coming down. Let's assume M2 is coming down. This one is coming down. And we are going to assume that the surface is rough. We assume the surface is rough. We're going to assume a rough surface. We are assuming a rough surface. Okay? So if this body, if this one comes down, then this has to go this way. Of course, it's as good as saying this is pulling this one this way. You can say this is pulling this way. I will say this is dragging down. As air goes down, air will go this way. But if we assume to go up, we say it should go up. If it goes up, that means this will come like this. This will go like this. Instead of this, it will come like this. Have this one come down, and air goes like this. Or this one goes like this, and air goes up. So they will tell you, you'll be told direction of motion of the bodies. You'll be told, like I said, this body is coming down, so air has to go this way, which means that if this one accelerates like this has to accelerate like this. That's the acceleration of air is downward, air is to the right. So tell me, if the surface is rough, it means there is friction. In what direction will friction go? What direction will friction go? What direction will friction go? So friction is okay. Mute yourself, thank you. Mute yourself. So because the body is moving like this one, friction does not affect this. Whether the surface is rough or is smooth, this is not making any contact with anything. It's hanging freely. It's not making any contact. This is not making any contact. Okay? But this one is making a contact. So because it's making a contact, if there is friction on this surface, it will affect the motion of this only. So if the motion of this one is to the right, then friction has to add to the left. That's friction. So you can now separate the bodies and deal with them independently or individually now. So let's still go to body 1. Let's see body 1. Let's draw the free body diagram for body 1. FBD means free body diagram, which means a diagram showing all the forces acting on the body. A diagram showing the forces acting on the body. So the body 1, let's deal with body 1 first. So this is body 1. Let's watch. This is body 1. Okay, you can make your line broken lines. You can make it broken line. This is body 1. What are the forces acting on it? Number 1 is sitting down on this. There's a weight. It has a weight. M1G. Weight of every object must always act downward. So it has a weight acting downward. And because there's a weight acting downward, the surface here provides this rough surface. This rough surface here provides a normal reaction. Let's call it a normal reaction R. A normal reaction what? R. And because this is attached to this with this rope, there's a tension on this rope. So let's say this is tension here. Tension T. Tension will always act away from the body you are considering. This is a tension force. It will always act away from the body you are considering. Tension always acts away from the body you are considering. There is a frictional force here which opposes the motion. So we have Fr. We have Fr. So we can resolve the forces in 2 ways. The motion of the body is or was intended to be like this. Motion was never up like this or down. This thing is meant to move like this or like this. It's not meant to move up or down. That means both the reaction and mg will be equal. So you can see that what? You can say summation of vertical forces equals 0. Summation of vertical forces equals 0. Where are the vertical forces? R and M1G are the vertical forces. R and M1G are the vertical forces. R is in the positive y-axis. Remember your graph. This positive y-axis, this negative y-axis. This positive x-axis, this negative x-axis. So, because motion is not, this body was not meant, it's not meant to move up or down. The motion was not intended to be up or down. That means our summation forces vertically will give us what? 0. So how are the forces vertically? R and mg. So we say well, R is also plus R because it's acting in the positive y-axis. This is acting in the negative y-axis. So we say what? Minus m1g equals 0. That means your R equals m1g. R equals m1g. Let's call this equation 1. Let's call this equation 1. Now that's for the first body. For the same body, there are also forces that are acting along the x-axis. There are forces that are acting horizontally. T is horizontal, Fr is horizontal. These are 2 forces acting horizontally. So the 2 forces, this T is trying to pull the body like this. This Fr is trying to pull the body like this or oppose the motion. Okay? But in the end of the day, the body was found to move like this. So you have what? The body was moving like this. Acceleration is like this. So horizontally, this is vertically. Horizontally, summation Fs will give us Ma. Take note of that. Will give us Ma. Why? Why is it giving us Ma? It's because the body actually moved horizontally. Why is this one 0? Because the body never moved vertically. The body did not go up, it did not come down. Why is summation of horizontal forces giving us Ma? Because the body actually accelerated horizontally. So that means what? Summation Fs equals to Ma. So where are the forces acting horizontally? You have to identify the forces acting horizontally. Where are they? T is acting horizontally. FR is acting horizontally. So T is acting in the positive x-axis. This is T, positive x-axis. FR is acting in the negative x-axis. So you say what? You say T is plus. FR is minus equals to MA. Which M is this? It's still M1, M1A, M1A. So you can say that what? T. Yes?
What does T stand for?
Tension. T is tension.
Okay, sir.
T is tension. Tension is because of the what? Of the rope. When you see a rope, you must have a what? A tension. When you see two bodies connected, you must have a what? A tension. So T is what? Tension on that body. So if you have this is a body connected by this rope. When you detach this from this guy, there will be tension on this rope. When you detach this from this, there will be tension on this rope. So T is tension on the rope. So we have what? T minus FR equals to M1A. So from this, you have T minus FR to M1A. But our FR is obtained using mu R. Our FR is mu R. That's formula to get friction. This is a formula to get friction. That means that what? FR equals mu. If you remember what R is what? M1G. So it's now mu M1G. So that's what we could get. This is what we could get for the first body. This is what we could get for the first body. Let's see what we can get for the second body. Let's see what we can get for the second body. Let's see what we can get for the second body. Copy that first. Copy it. Copy this one first, please, so I can see what we get for the second body. Or can you work on the second body and tell me what you get? Can you work on the second body and tell me what you get? Can you work on the second body and tell me what you get?
Yes, sir.
Yeah, work on the second body and tell me what you get. Yeah, fast. I'm done with the first body, body 1. And these are the equations I get. I got this equation 2, equation 3. So I'll replace FR. FR will be replaced with, will be replaced with this. I'll replace FR with this expression. So I've assumed there's a friction here. I've assumed there's friction. So let's see what we will get for body 2. Okay, for body 2, we have, this is free body diagram, body 2, free body diagram. Okay, so you can see your body 2. This is a rope. There will be tension on this rope. There will be tension on that rope. This body has a weight. So this is the weight acting downward, which is M2G. This is your body 2, and it's moving downward with acceleration A. This tension here. Whenever you detach this body from this rope, there will be tension left on that rope. So this is the tension here. This is M2G. So you have, again, summation Fy equals to Ma. Why? In this case, it's just only what? It's just only vertical forces. We have vertical force. These are vertical forces. And the body is moving vertically downward. So in this case, just watch it, there will be no summation Fs at all. Why won't there be summation Fs at all? There is no any horizontal force acting here at all. In the body 1 I did, I said summation Fs equals to Ma. Why? Because the body was acting horizontally. This force was horizontal, this force was horizontal, and the body was moving like this. So because the body was moving horizontally, the summation Fs will equate to what? To Ma. Its Fs will equate to what? To Ma. But if the body is moving vertically, that either up or downward, is Fy equates to Ma. So that means what? What are the vertical forces now? Like I said, this is positive, this is T, so plus T. This is what? Minus M2G. Because this is positive, this is positive, this is negative, you can see. Positive y-axis, negative y-axis. So positive T because positive y, negative because negative what? Y. So you have what? Plus T minus M2G equals to minus MA. Why is MA negative? Why is it negative? It's because it's coming down. It's coming down. So anything down like this is negative. So you have what? Minus MA. So you can now say that what? You can say T equals M2G plus M2A. This is M2A. You should know why this is negative because the acceleration is also acting downward, so it's negatively downward. Negatively downward. It's as good as saying M2G minus T equals to what? M2A. So take note of that. So this is what equation 4. We have done 2 and 3 before. Okay? So that's this body. Let's see the second connected bodies, and that will be earthwood machine. Let's see the earthwood machine. The earthwood machine. Let's see the earthwood machine. Now for the earthwood machine consists of 2 suspended bodies. Earthwood machine consists of what? 2 suspended bodies. We have 2 suspended bodies. Okay, so these are the bodies. Watch. If you have this as a pulley hanging a body of mass M1, another pulley hanging a body of mass M2, these are suspended masses. Okay, now in those ones I did, one was suspended, one was sitting. One was suspended and one was sitting. But in this one, the 2 masses are suspended. They are not making any contact with anybody, with any surface. There means friction cannot affect their motion here, unless if the pulley has friction. So we assume here the pulley is frictionless. We assume in fact all the pulleys we use are assumed to be frictionless. We are using frictionless pulley. So this is what? Earthwood machine. An earthwood machine consists of suspended masses that are suspended. You can have more than what? More than one mass suspended. You can have 3 masses suspended. We are dealing just two bodies which are connected. Connected bodies are just 2 bodies alone. You don't want to go beyond 2 bodies. You can have 3 bodies, you can have 5, you can even have 20 bodies connected together. Good. But the same principle will be followed. Once you detach the bodies, tension must follow. For instance, let's see the free body diagram. Free body diagram for body 1, for body M1, for body M1. So let's this body M1. Let's look at it. We want to find the tension on the rope. The tension here and tension here are the same. Tension here and here are the same. Why are the tensions the same? It's because this is a single pulley. It's a single wire. This is a single wire. Take note of it. It's a single wire. A single pulley. As far as a single pulley, tension here and here will be the same thing. So let me draw the first body. Body 1. This is body M1. This is tension. And this is what? Weight. You should know that. M1G. Everybody must have his weight acting what? Vertically downwards. So if, let's assume, this body is going down. An assumption with acceleration what? A. Let's assume this body is moving downward with acceleration A. And this body is moving. This is not an assumption. You can see this body is assumed to come down. It's an assumption for this to come down. And as air comes down, it will drag this up. Okay? As air comes down, it drags this up. Okay? Now, if I look at that, if air comes down, so I'm saying that what? motion of this is vertically downward. So it's a vertical downward motion or vertical upward motion. So that means what? Summation Fy will be equals to MA. You know why summation Fy equals to MA? Because the motion of these guys is either vertical downward or upward. There is no horizontal motion at all. Nothing is moving horizontal, so there is no Fs at all. S is horizontal, Y is vertical. You can see. So summation Fy, where are the Fy? Where are the Fy? We have, in this case, the Fy are tension and M1G. Tension and M1G. So this acting upward, that's positive Y. So you have plus T. This acting downward, that's what? Minus M1G equals, this acceleration is downward, minus M1A. That is it. You can see that. You can see it. You can have say that what? T equals M1G minus M1A. T equals M1G minus M1A. Let's call this equation what? 1 for this. It's as good as saying M1G minus T equals to MA. M1G minus T equals to MA. So it's the same thing. M1G minus T equals to MA is the same thing as what you will get here. What I did here is, so Fy equals to MA. Anything that is upward like this takes positive value. Anything downward takes negative value. This is what? Up, positive. This is down, negative. Acceleration is downward, negative. So you can see I've arranged. This one goes here, it becomes plus. That's M1G minus M1A. That's T. That's equation 1. Then for body 2, let's see body 2. Free body diagram for body 2. For body M2. For body M2. But we must solve the two equations. We can solve the two equations. So for body 2, we have this body 2. This body 2, there's tension. There was a tension and there's weight. M2G. This is body 2. You can look at it. Body 2 is here. It has a weight. And once you detach it, if you convert it here, you remove it here, you remove this guy here, you will be left with tension on this rope. And that's tension on that rope there. Okay? So what am I saying now? Just look at it. So the motion of this thing is upward. It has no choice because I have zoomed this way downward. Once here is downward, it will come down like this, fully down. The ear will be going up. You can see. You can see. So once here is downward, here must be upward. If here is downward, here must be upward. So that there is no, you don't have any, what's it called? You don't have any choice. Here has to be upward. So what do you see? It's vertical motion. No S at all. No, nothing horizontal here at all. So you say what? Summation Fy equals MA. Where are the Fy? This is positive. So positive T. This is negative minus M2G equals, this acceleration is upward. So upward means plus MA. This is plus MA. You know why A is minus MA? Because it's downward. Here is minus MA, is downward. So we now say what? T equals M, that's M2 anyway. That's M2G plus M2A. This is that and that. Okay? So M2G plus M2A. That's the what? The tension. That's the tension on that body. That's the tension on that body. It's simple. Very simple. Very simple. If you have any question, you can just what? You can just chat me up. It's very simple. If you have any question, just chat me up. So let's rub it and now deal with these two equations. Let's deal with the two equations. So equation 1 says T equals M1G minus M1A. 2 says T equals, that's 2, M2G plus M2A. Of course, you know you can equate the two of them. You can equate them. You can equate the two of them. You can say T equals to T. T equals to T. Can equate the two of them. So that means what? First T, look, tension will be the same thing. Tension here and here are the same. Why? It's a singular rope. is single row, one row for everything. You only have different tensions if the ropes are different. For instance, if I join another body here now, for instance, under this one, M3, then the tension here and here will be different from this. This will have the same tension because the rope continues, no mass between them. But this has a different tension from others. If I disengage this one, for instance, if I disengage this, if I bring this one out now, I will say body 3, watching M3. It has a weight, M3G, no choice. Everybody must have weight. And it has a tension, let's call it T2. And here we call T1, T1. The tension will be what? T2. So you can now form the equation and continue, okay? So therefore it's not there, so it's not there. It's not there, so there's something like that. Same tension, so TT. Same tension, that's TT. So what's the first T? M1G minus M1A equals M2G plus M2A. So what do you have here? So you have M1G minus M2G equals M2A plus M1A. If you rearrange, you bring this one here, M1G minus M2G. You take this one there, that's M2A plus M1A. If I make a mistake, there's a mistake on the board, you can correct me later. It's possible. So I brought this one here, and I took this one there. M2A plus M1A. Here is M1G plus M2G. I don't think there's a mistake yet. I don't think so. So what's common here? G is common. You have M1 minus M2. What's common here? M2 plus M1. A is common. I can therefore say that what? A is what? You bring this thing under here. A will be M1 minus M2 all over M2 plus M1 times G. I bring this one under here. I want to leave A alone. So bring this one under this place. So you have A as this. So acceleration of the masses, A will be equal to M1 minus M2 all over M1 plus M2 times G. But the G is multiplied what is up there, not down, times G. Now what happens? What happens if M1, just watch, if M1 equals to M2, what happens? Let's say 1. What happens if M1 equals to M2? What happens if M1 is much greater than M2? What happens if M2 is much greater than M1? What happens if all these cases we hold? What happens if M1 equals to M2? What happens if M1 is much greater than M2? That means M1 is so great, it's so much, like a 1 kilogram and a 1,000 kilogram, that's 1 ton. If you have 1 kilogram body, if you hang a 1 kilogram body here, you now hang a 1,000 tons, 1,000 kilogram body here, or 1 ton. You should know that this will come down straight. It will just go down because this is too heavy for this. But if you add 2 kilogram and 3 kilogram, well, they will balance a bit. But if you add 500 grams here, watch your 500 grams. 500 grams is 0.5 kilograms. If you add 500 grams here, or 0.5 kilogram here, you now add 1,000 kilograms here. Of course, you should expect that this should drag it down. You should take it down. You should take it down. Here will be insignificant. You should take it down straight. So, what happens if M1 equals to M2? If M1 is much greater than M2, or if M2 is much greater than M1, what happens to this equation? Let's see what happens to the equation before we now come back to tension. This is what? Finding this acceleration. Title this one as what? Finding acceleration. Acceleration. This is finding acceleration. Okay? This is the acceleration I've gotten here now. That's the acceleration I've gotten. So let's see what happens to these 3 cases I've highlighted. Let's see what happens to them. I will still come back to our equations. Okay? We said A equals M1 minus M2 all over M1 plus M2 all times G. So number 1, if M1 equals to M2, acceleration will be 0. You can see that yourself. There will be no acceleration. Just check it yourself. If m1 equals to m2, a will be 0. You can see it yourself. Look at it now. m1 equals to m2. m1 equals to m2. That means m1 minus m2 becomes 0. If m1 is 10 kilograms, m2 is 10 kilograms. That means 10 minus 10 is what? 0 already. So that means what? 10 minus 10 over 10 plus 10 times g. That is 0 over 20 times g. That's 0. A will be 0 if they are equal. That means what? If these masses are the same, nothing will go up, nothing will come down. They will all be stagnant like this. They will just stay there. Just like what? Having a 10 kg here, a 10 kg here. Who should drag you down or up? Nobody. They will balance because they are equal mass. Let's see number 2. Number 2. If m1 is much greater than m2, watch my word. It's much greater. That means that what? They're not comparable at all. It's so more than m2. It's far more than m2. What would that be our A? Our A will become m1 minus m2 all over m1 plus m2 times g. Let's see it now. Who can tell me what's m1 minus m2? If m1 is far greater than m2, what will be m1 minus m2? You can guess that. What will be your m1 minus m2? m1 minus m2 will be approximately equals to m1. Look at it now. We said what? m1 is much greater than m2. m1 is much greater than m2. That means that what? m1 minus m2 is approximately equals to m1. How? Let's say you have here as 1 million kilogram. 1 million kilogram. 1 million kilogram. Here is just 0.1 kilogram. What will be the answer? Subtract 0.1 from 1 million. The answer is 1 million. Or should we put money? Okay, you have 1 million in your account and 0.1 naira removed from 1 million. Will you know that anything has left your account? No. Or you have 100 million in your account and somebody removed 1,000 from that 100 million. What's still left in your account? It's still 100 million. Because it's so much down, it's much more than what? Than 1,000 naira. So when you have m1 far greater than m2, then m1 minus m2 is approximately m1. Also, m1 plus m2 is approximately m1. Sorry? Yeah, I think I'm correct. M1, I'm correct. Just watch it yourself. 100 million naira. 100 million naira plus 1,000 naira. Can answer? 100 million naira. No difference. It's still 100 million naira. No, there's no difference. So it's m1. Therefore, A will become equal to m1, m1 minus m2 is m1 over m1 plus m2 is m1 times g. And the answer is what? Is g. So A is approximately equals to g. A is approximately equals to g if m1 is far greater than m2. You have to watch that. You have to watch that. Let's see the third one. The third one says, what if m2 is now much greater than m1? That's number 3. If m2 is much greater than m1, then that means that what? That means that m1 minus m2 will be approximately equals to minus m2. Just look at it. 1 million. 1,000 naira is a small value. This is m2 is now big now. M2 is big. So let's see now. 1,000 minus 100 million. 1,000 minus 100 million. Let's say 2 minus 3 is minus 1. 4 minus 5 is minus 1. 8 minus 15 is minus 7. So what do you have here? 1,000 naira minus 100 million. It will be minus 100 million. It will be minus 100 because that 1,000 has no effect It has no effect, but because this is bigger than this, it will carry minus. Also, M1 plus M2 will be approximately equals to what? M2. Because 1000 plus 100 million is 100 million. So answer, your A will become M1 minus M2 is what? Minus M2. M1 plus M2 is what? M2 times G. Times G. What do you have now? A will be approximately equals to G. That means that what? Acceleration will be what? Negative. Why should the acceleration be negative? Because I have said initially that M1 is coming down. If M1 is one coming down, it means that most likely M1 is greater than M2. If M1 is one coming down, watch you. If you put heavier object here, you put a light object here, the heavier will do or drag the light one down. So here will go down, here will go up like this. Here will come like this, here will go like this. So by our assumption, by this assumption, we've assumed that M1 is greater than what? M2. We now did the reverse. We now say, what if M2 is now more than M1? Then we now get the reverse. M2 is more than M1. Then here should come down, here should go up. So our A is negative, showing that what? Direction should change. Direction should change. Alright. So let's see the third case. Number 3. Let's see the third case. Let's see pulley and inclined plane. Pulley and inclined plane. That's the third case. Pulley and inclined plane. Pulley and inclined plane. An inclined plane. An inclined plane. Pulley and inclined plane. So if you have this body on the inclined plane, watch this. This body 1 on the inclined plane. I want to assume there is friction on this inclined plane. I want to assume it's a rough inclined plane. I want to assume this is rough. If it's not, if the question says it's smooth, just equate friction to 0. But let's assume it is rough. So we take care of every parameter. So this is your pulley. This is a pulley on which the second body is attached. This is the horizontal surface. This is angle theta. So let's call this body 1 and call here body 2. So mass M1, here is mass M2. Don't forget that this is suspended. This is suspended. It's hanging freely. It's not making any contact with the surface. It's not making any contact with the surface. You can see this is surface. It's not making any contact at all. It's not making any contact at all. Not making any contact at all with the surface. Any contact, you can see. It's just hanging freely. Let me just withdraw. So this is the inclined plane. This is body 1. That's the pulley, and this is body 2. Okay, so from this, you can decide to separate the body. Let's disengage them. Now, before you go on, this body 1, from the previous class we have had, this body 1, there are some forces that act on it naturally. I've told you, there will be mg sin theta, there will be mg cos theta, there will be normal reaction on this body alone. There is now tension again, and there's friction acting against. Let's assume the bodies are going, this body going like this, accelerating upward like this, and this will come down, obviously, because here is going up, here will come down. So if you look at this, let's start with body 1. Free body diagram for M1. So if you look at M1, this is a body here. Naturally, there is mg sin theta here. Mg sin. Naturally, there is mg cos. We have done all these. and naturally there's a normal reaction R. And there's a tension here, you can detach it. So there's a tension here. This tension, T, and we say the body is going like this, it's going up like this, it's our assumption. So it's accelerating upward like this, accelerating upward like this, like we said here. And here will come down. Now because it's a rough surface, it's rough, there will be what? Frictional force that will act against motion. Frictional force will act against what? Against motion. Okay. So what do we say here also? We say what? Summation of forces. Summation of forces along the plane. Along the plane equals to 0. Summation of forces along the plane equals 0. Let's take upward. Let's take upward as positive force. And let's take downward as what? Negative what? Force. Okay? We want to take anything upward as positive force. We want to take anything downward as negative what? Force. Okay? I recall that. I want to recap that. Anything that is going up like this, let's take it as positive force. Let's equal to 0. Sorry. Equals to MA. It can't be 0 now. It can't be 0 because there's a motion along this place. It's going up and it's going up actually. So let's take anything up, positive, anything down, negative. So let's go. Where are the forces now on this inclined plane? We say along the plane. These are the forces 1, 2, 3. So we now have what? T is plus, because we said anything going up should take plus, anything coming down should take what? Minus. So T is plus. So this minus FR minus what? Mg sine equals to MA. Is it minus MA or plus MA? Is MA going up? A is going up also is what? It's plus MA. It's plus MA. That's T minus this equals to MA. So you can see that what? Our T will be equals to MA plus frictional force plus Mg sine theta. Which M is this? M1. The mass is M1, mass 1. This is for the 1, M1. This is M1. It's for M1. That's what equation 1 for this place. Then there's another thing we have to do. We have resolved the forces along the plane. We also resolve the forces perpendicular to the plane. Perpendicularly to the plane. So we say what? Summation of forces perpendicularly to the plane. Perpendicularly to the plane. Perpendicular to the plane equals 0. These are long. And long means like this. These are long. Perpendicular, this is it. Because we equal to 0. Hope you know why it's 0. You should know why it's 0. Because motion is not up or down. Motion is not up or down. Have you now? So it's equal to what? To 0. So you have what? Where are the forces perpendicularly? Let's take up as plus. So plus R. Another one is this. These are the two forces that are perpendicular to the plane. Minus what? Mg cos theta equals 0. So R equals to Mg cos theta. Let's call this equation what? 2. Don't forget, once you hear an inclined plane, go and check the previous lectures. This is a must. This is a must. This is a must. Once you draw inclined plane, put this, and put this. It's a must. They are not optional. 1, 2, 3 are not optional. So R is Mg cos theta. R is Mg cos theta. Okay? Now, if we look at okay, so if we look at the second body, this is for the first body. For the second body, this is what? Second body, M2. That's M2. Let's do M2. So we have seen equation. Okay, you know what this R is used for? R is for to calculate what? FR. You know that FR, the frictional force, is mu R. They will give us the coefficient of friction. That's equation 3. We will given the coefficient of friction. We will given the coefficient of friction. That's equation number 3. Alright, so let's see the second, what's it called? Second body. So that's gone, that's settled. Let's see second body. For the second body, what do we have also? For the second body, what do we have also? Look at it. This is what? Body M2. This is body M2. That's body M2. So this is the retention, because we are detaching this from the, it's a single rope. So it's the same tension. It's just one rope. It's the same tension. There's what? MG, M2G is his weight. That's all. You can see. It's hanging freely. It's not making any contact with this. If it was making contact, we'll start talking about friction. We'll start talking about normal reaction. There will be friction, and this one will have friction and normal reaction. This one have no friction or normal reaction. The pulley we are using is always frictionless. In the question, they will say the pulley is frictionless. They will say frictionless pulley. They will say frictionless pulley. They will say frictionless pulley in questions. So pulley is always assumed to be frictionless. So let's go. So you have said it's coming down. You can't change it because E has gone up because of an equation. So E has to come down. So here is coming down with A. It has to come down because E has gone up. If here goes up, then E has to come down. So like this is pulling this. As here comes like this, here follows. You can see. You can see. As you pull here down, here will be going up like that. Okay. So what do we have here? Summation Fy will be equals to Ma. Why? Because there's a motion along this plane. There's a motion along here. Just like here, there's a motion along here, also along here. So we say equals to Ma. Along perpendicularly, there's no motion, so equals to 0. This body is not going like this, it's not coming like this. So perpendicularly equals to 0. Perpendicularly, we'll put this as 0. Perpendicularly. But along the plane, it will be equals to Ma because it's moving along. So also this one. This is coming down like this. So it's equals to M because this guy is moving down truly. Equals to Ma. So T is positive Y, so it's plus T. This minus M2G because it's down. Equals to what? Already Ma. Is it plus Ma or minus Ma? It should be minus Ma. Minus M2A. Abi? Of course. So you can say that what T equals to M2G plus minus what? M2A. This is equal to what? 4 for this aspect. Alright, so we hold it there and we'll do examples. I'll first give you this example as assignment. So you're right. We get this example as assignment. You get examples as assignment. So apply this principle and solve them for me. So examples stroke assignments. Examples stroke assignment. All this will be done in the next class. They will be solved in the next class. So right. Okay, let's write assignment stroke example or example stroke assignment. Right. Example, right. Right. Number 1, a load of mass M1 equals 2.5 kilograms. M1 equals 2.5 kilograms is attached to a mass M2 equals 4.25 kilograms. 4.25 kilograms with a light inextensible string. Inextensible string hanging over a frictionless pulley. The pulley is always frictionless, I've told you. Hanging over a frictionless pulley. Full stop. If the two lobes hang freely in air, what is the acceleration of M1 upward? That means M1 has to go up. That's the meaning of upward there. What is the acceleration of M1 upward? Number two. A mass M1 equals 6.5 kilograms. 6.5 kilograms is attached to a mass M2 equals 3.75 kilograms. To a mass M2 equals 3.75 kilograms. With a light inextensible string, passing over a frictionless pulley as shown in the figure below. Passing over a frictionless pulley as shown in the figure below. Question A. What is the minimum coefficient of static friction? Question A. What is the minimum coefficient of static friction? What is the minimum coefficient of static friction that will keep the system of masses stationary? Stationary. Question mark. B question. If the coefficient is reduced to 0.25, what would the acceleration of M2 be? What would the acceleration of M2 be? That's mass 2. Number 3. Okay, this diagram. They give you a diagram, so you draw it. This diagram. They drew there. They put 6.5 kg on this. And this is a pulley. Something like this. And they put here 3.75 kilograms. 0.75 kilograms. So you have this. Okay, that's question 2. Number 3, please write. Number 3. If the angle of the inclined in the figure below, if the angle of the inclined plane in the figure below, is gradually decreased, at what angle of inclination will the masses stop accelerating? At what angle of inclination will the masses stop accelerating? This diagram. The angle is 45 degrees. This is M2, M1, M2. M1, M2, this is 45. So that's it. So to find the what? At what angle of inclination will the masses stop accelerating? Finding what angle? That is 45 will reduce to something. What will it reduce to before this body will stop moving? Alright, so we stop here for now. In the next class we do the correction to this assignment. So see you in the next class. Thank you and good afternoon.